isosceles, so that means that these sides are congruent. That's what isosceles means. It means that these angles are congruent. And that's what it says here. AB is congruent to BC. That's the definition of an isosceles triangle. The ray BD bisects the angle ABC. Well, that's by construction. They drew it that way. So that makes those two angles congruent. These are congruent and those are congruent. So angle ABD is congruent to CBD, and that's the definition of an angle bisector. When you bisect an angle, it creates two congruent angles. BD is congruent to itself because of the reflexive property again. And now we are proving that these triangles are congruent, and then we have a side, an angle, and a side. So this is congruent by the side, angle, side property. Alright, here we go. Angles 1 and 2 are congruent. Angles 1 and 2 are a linear pair. Those are our givens. That's what they're telling us. We're going to prove that this is a perpendicular line. P is a perpendicular line. So angles are linear pair, that's given. Angles 1 and 2 are supplementary because that's the definition. That's the linear pair postulate. When you have a linear pair, they're supplementary. That means that the measure of angle 1 and the measure of angle 2 are 180 degrees. That's the definition of a supplementary angle. And now we know that these angles are congruent. That's given. Okay? And that means the measure of angle 1 is equal to the measure of angle 2. That's the definition of congruent triangles. So now, since they are equal to each other, we can place angle 2 with angle 1 because they are congruent, okay? And that's the substitution property. So now we have 2 times the measure of angle 1. We just combined our like terms here. That's the distributive property. And the measure of angle 1 is equal to 90 degrees, and that's because we divided 180 by this 2. And that's the division property of equality. Whenever you're solving an algebraic equation, that's from algebra. Well, angle 1 is a right angle because if it equals 90 degrees, that's the definition of a right angle. So P and Q are perpendicular because that is the definition of perpendicular lines. Given that they're supplementary. So here it's saying the measure of angle 1 plus, so what we've already seen this before. When you add the measures together and get 180, because they're supplementary, that is the definition of supplementary angles, which I totally selected the wrong one on accident, trying to see what my time was. Alright, here we are again. Theorems and proofs still, sorry. Okay. So now we have that these two lines are parallel. Where's my snippet? I like to draw. So these two lines are parallel. Okay? We're going to prove that angle 1 is congruent to angle 3. Okay? So first we're given that the two lines are parallel, and angle 2 is congruent to angle 3. So we need to know angle 2 is also congruent to converse because we're proving that it's parallel. Whenever you're proving something's parallel, that's the converse of it. Two lines cut by a transversal, a pair of congruent corresponding angles are parallel. Because that's what we did. We did two lines cut by a transversal as a pair of congruent corresponding angles are parallel. That's what we just put here. Alright, we are given that all of these lines are parallel to each other, cut by one transversal, and those are our givens. Okay, angle 1 is congruent to angle 3. Hang on, I'm going to draw it. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3. Those are corresponding angles. Okay. And it's that we've already said that they're parallel, so it's not the converse. Or so corresponding angles postulate says that when lines are parallel and cut by a transversal, corresponding angles are congruent. Alrighty, theorems and proofs. Okay, here we go. So now we have ST is the perpendicular bisector of PR. So since it's perpendicular, what do we know about that? Perpendicular means this is a right angle. Okay, so now they're saying, and it's a bisector. Look at that word, bisector. So that means that this is congruent to this because it's bisecting that line. That's what bisecting means. So PQ is congruent to QR or RQ, and that is the definition of a perpendicular bisector. Let's see. Perpendicular segments for angles of equal measure. A bisector, there we go. A bisector divides a segment into two congruent segments. Here we go again. Alright. So here we are given that angles 1 and 2 are complementary, means they add up to 90 degrees. And angle 3 and 4 are complementary. So that's our given.